Today we are going to present assignment 2, which is Industrial 4.0, and our topic is Internet of Things, which is IoT. So we are four of us: Nur Afifa, Nur Fazli, Iman Aida, and myself, Pavitra Anandrao. Next. First of all, we are going to see the objective of IoT. Firstly, to analyze a novelty of the theme Industry 4.0 related to IoT. Second, to analyze a common standard and protocols for communication between IoT. And the last, to identify the terms, components, and application that forms part of IoT architecture. Next.
Okay, for the introduction, I am Afifa. Will present the introduction of Industry 4.0. Okay, the Industry 4.0 movement was first described in Germany in the German language during the Hanover Fair in 2011 as a proposal to establish a new definition of German economic policy focused on high technology strategy, symbolizing the beginning of the fourth industrial revolution. Okay, this is the Industry 4.0, which is autonomous robots, system integration, Internet of Things, simulation, additive manufacturing, cloud computing, augmented reality, big data, and lastly, cyber security. Okay, the workforce has been replaced by passive machines and robots, which mean that a human being without consciousness manage them. Okay, the technical implication of this requirement presentation are discussed for the concepts and the industrial Internet of Things IoT. Okay, next. Okay, Internet of Things IoT is enable physical object to see, hear, think, and perform jobs by having them talk together to share information and to coordinate decision. The IoT transforms this object from being traditional to smart by exploiting its underlying technologies such as ubiquitous and pervasive computing, embedded device, communication technologies, sensor network, internet protocols, and application. Okay, smart objects along with their supposed tasks continue domain-specific applications. This smart home, which is vertical markets, while ubiquitous computing and analytical service from application domain independent service, which is horizontal market, transportation, industry, market, school, healthcare, agriculture, and vehicles. Okay, next.
Okay, I'm going to explain about the methodology. First of all, purpose and requirements, which is define purpose and requirements of IoT system. Second, process model of specification, define the use cases. Third, domain model specification, which is define physical entities, virtual entities, devices, resources, and services in the IoT system. Fourth, information model specification, which is define the structure, for example, relation and attributes of all the information in the IoT system. Fifth, service specification, which is map process and information model to service and define service specification. Sixth, IoT level specification, which is define the IoT level for the system. Seventh, functional view specification, which we can define as map IoT level to functional groups. 8. Operational view specification, which is known as to define communication options, service of hosting options, storage options, and device options. Ninth, device and component integration, which is integrate devices, develop and integrate the components. And finally, application development, to develop the application of IoT system. Next.
Okay, thank you, Pavi. So now I'm going to talk about literature reviews. So from the literature reviews, we get the common IoT standards. So every networking will have their own standards and protocols. So this is the standard and protocol of IoT. So first is the infrastructure protocols, where they include RPL, 6LoWPAN, IEEE 802.15.4, Bluetooth Low Energy, that is BLE, EPC Global, and for the next part, category of standards are the application protocols, where it include 5. There is COAP, MQTT, XMPP, AMQP, and DDS. And while the other one is the Service Discovery Protocol, SDP, when it includes 2 DNS protocol, that is MDNS, DNS-SD, and the other stuff are other influence protocol are Security IE 1905.1. So other than that, we got to get the application of IoT, where it includes smart grid, that is almost like smart city or smart home, but city category, and consumer device and report maintenance to get get to use the IoT. Asset tracking, when is widely used for nowadays for transporting asset and other stuff. Smart health, when for example, when the doctor can check the patient situation even without being there. And lastly, the security and public safety, where the internet can be used widely and can detect criminal easily in now era. So the next is result.
Okay. My name is Nur Fazlin, and I will present about the result, where here some of the application use case that are used to indicate the readers how the key protocol work together to provide the desired IoT application features. So application number 1 is nursing home patient monitoring system, where this is the use case that involve the compilation and distribution of vital sign measures by patients to various nursing stations. So a light sensor and a dose sensor were deployed to track patients' level of operation. The sensors can use ZigBee or Z-Wave for communication to collect the measurements on the platform. Okay. So the single board computer, which is SBC microcontroller or processor, is used to offer a better alternative for the combination of hardware and software components from various suppliers. The node sensor can use Wi-Fi or IEE to transmit their measurement. And in addition, developer can install an open source MQTT broker like Mosquito to implement a client running on the SPC associated with USB sensor that capture vital sign, illumination, and door sensor data. Okay, so next. And now we assume that the application will be extended to enable people with extreme tremor or Parkinson's disease to eat without food spillage. In this case, the glove can be fitted with tiny MEMS vibrating motors to overcome the volatility of hand motions calculated by accelerometer. The DSS protocol would be the best option for this scenario to allow limited direct contact between the accelerometer and the vibrating motor engines without the intervention of the broker. A gateway must be used to convert DDS message to MQTT in order to enable such integration. Okay. However, expanding the functionality of MQTT-based solution can be easily achieved as a new sensor that can cause a single broker implementation suffer from failures or performance bottlenecks. In such cases, a solution involving several brokers is required and becomes a fascinating problem. Okay, next. Okay, assume that we extending of the application further to utilize the constellations of decay wave or nanotron transceivers to deliver real-time location service, which is RTLS to users. Okay, MDNS may use to connect to a local server, receive an authentication token to access RTLS services. The RTLS nodes will then transmit the obtained data to the local RTLS server in order to approximate the current position of the user. Okay. Lastly, the local RTLS server will overlay the position on the floor plan obtained from an internet connected server to provide user with tactile navigation information that helps them to escape obstacles. Okay. That's all for result. Next. Oh, right. This is the illustrations of the use case application that mentioned just now. Okay, next.
Okay, thank you, Fasil. So what we have discussed is that we have talked about QoS criteria versus IoT challenge. So the availability of the hardware and software, the security and privacy, where the key feature is sharing of information, the reliability in proper operation of the machine, mobility, where supposed to be provided to smartphone device and other little device that people can be used. The performance, where continually involve and expand its offering to meet the needs of the community or company, and as management, where it provides service providers with challenging difficulties, scalability, where the incorporate additional products, system, and features, interoperability, where it manages a vast range of the heterogeneous humans item. So,
Okay, lastly, conclusion of the assignment 2, Internet of Things, IoT is Industry 4.0 is a transformative technology. Okay, Industry 4.0 is also seen as a transformative technology that will pave the way for a new generation of modern production system that will be radically different from the current ones. Okay, next is the the fourth industrial revolution was the first industrial revolution that was declared in advance and not when it was already fully established. Okay, this view needs a closer look. Okay, on the other hand, throughout our modern life, the new concept of the Internet of Things (IoT) is increasingly finding its way, helping to enhance the quality of life by connecting multiple smart devices, innovations, and applications. Okay, overall, the IoT will allow for anything around us to be automated. Okay, lastly for the summary, various aspect of the Internet of Things (IoT). Okay, this paper provide a summary of the concepts, premise, its supporting technologies, protocols, implementations, and recent research that discuss various aspects of the Internet of Things. That's all. Thank you.